For a century, Americans were told that the soul of a serious car lived in its engine, its gearbox, and the mechanical intelligence buried inside Detroit's steel. A great transmission was supposed to be felt through your right foot. A great drivetrain was supposed to react to torque, load, throttle, heat, and road speed with the brutal honesty of metal against metal. But the Lynk Co 10 EMP forces a more uncomfortable question: what happens when the gearbox is no longer the brain of the car? Because this is not just another Chinese plug-in hybrid chasing range numbers. It is a warning shot from Geely's industrial machine. Under the bodywork sits a system where the combustion engine, electric motors, battery, suspension sensors, and transmission logic are no longer separate departments arguing through slow electronic channels. They are being pulled into one predictive nervous system, powered by centralized computing, and trained to think miles ahead of the driver. That is the real threat. Not horsepower, not leather, not another screen across the dashboard. The threat is that Geely may have turned the hybrid drivetrain into a software-controlled energy weapon, while many legacy automakers are still treating transmissions like mechanical kingdoms to be defended. For years, many Western analysts looked at Geely and saw a company collecting brands. Volvo was treated as a prestige acquisition. Polestar looked like an electric performance experiment. Lotus looked like a trophy from Britain's sports car past. Zeekr looked like another Chinese EV label trying to climb into the premium market. On paper, it seemed like diversification. In reality, it may have been something far more strategic. Geely was not simply buying badges, it was absorbing engineering languages. From Volvo, it gained a culture of safety architecture and crash protection discipline. From Lotus, it gained an understanding of balanced suspension geometry, steering response, and the strange art of making a heavy object feel lighter than physics wants it to feel. From Zeekr, it gained high-voltage thinking, digital cockpit systems, EV manufacturing speed, and software-defined vehicle development. That is why the Lynk Co 10 EMP matters. It is not the work of one isolated engineering team trying to build a better plug-in hybrid. It is the visible result of a corporate ecosystem where safety, chassis dynamics, battery packaging, compute power, and hybrid energy management are being fused under one industrial roof. This is the part Detroit should study carefully. The threat is not that a Chinese automaker built one clever transmission. The threat is that Geely built the organizational machine required to make the transmission, the engine, the battery, the software, and the chassis behave like one coordinated weapon. To understand why this machine feels so threatening, you have to stop thinking about it as a normal car with better software. For decades, the automobile was an empire of small electronic kingdoms. One control unit managed braking, another handled fuel injection, another watched the transmission, another tried to keep the infotainment system alive. They communicated through layered networks, miles of copper, and a design philosophy built for an age when software was an accessory to the machine. That architecture worked when cars were mostly mechanical, but it becomes a liability when the vehicle must process LiDAR radar cameras, battery temperature, motor torque, road friction, suspension, movement driver input, and route prediction at the same time. In that world, latency is not just an inconvenience, it is industrial weakness. A slow signal becomes wasted fuel. A delayed torque correction becomes lost traction. A fragmented system becomes impossible to update at the speed of the market. The Lynk Co 10 EMP attacks that weakness with centralized compute. At the center is the idea that the car should not be a committee of disconnected modules. It should be a single nervous system. The reported NVIDIA Thor U platform, with up to 700 TOPS of computing capacity, is not there simply to impress people with a number. It exists because this vehicle is trying to collapse the old ECU hierarchy into one high-speed decision layer. That changes everything. The same logic stream can read sensor data, manage battery temperature, prepare the hybrid system, adjust damping force, and coordinate torque before the driver feels the problem. A pickup driver in Colorado understands this instinctively. When a heavy vehicle is climbing, turning, and carrying load, every delay matters. Traditional systems react after physics arrives. A centralized system tries to meet physics at the door. This is why the old gearbox feels exposed. Not because gears vanished, but because the decision-making authority moved upward away from metal alone and into computation. The most dangerous part of this system is not the engine itself. On paper, a 1.5-liter turbocharged combustion engine in a plug-in hybrid does not sound like an industrial earthquake. Detroit has seen small engines before. Toyota and Honda have spent decades refining hybrid efficiency. But Geely's approach changes the question. It is not asking how much power the engine can make. It is asking when the engine should exist in the driving event at all. Traditional hybrids are mostly reactive machines. You press the accelerator. The system reads throttle position. It calculates load checks. Battery state wakes, the engine blends electric torque and tries to make the transition feel smooth. That was brilliant when hybrids were designed to save fuel in city traffic. But on an American highway, with speed, heat, elevation, cargo, and long-distance driving, reaction is no longer enough. The Nord-Thor AI Hybrid 2.0 idea is more aggressive. It turns the transmission from a mechanical responder into a predictive energy strategist. The system can use road data, navigation, traffic density, elevation changes, battery condition, and driver demand to prepare the drivetrain before the load arrives. If a long climb is coming 3 miles ahead, the car does not wait until gravity starts punishing the wheels. It can bring the combustion engine into its most efficient operating zone, early align electric torque, and prepares the 3-speed DHT before the road begins to fight back. That is where the claimed 46.1% thermal efficiency becomes more than a laboratory number. Efficiency only matters if the vehicle can stay inside the right operating window. In old systems, the engine often chases demand. In this system, the demand is forecast before it arrives. Every gallon of fuel is treated like a tactical resource. Every electron is placed where it can do the most damage to waste. Imagine towing through western Colorado. A conventional drivetrain feels the hill, then responds. A predictive hybrid sees the hill, prepares the engine balances. The battery chooses the ratio and builds torque before the driver asks for it. That is why the phrase AI transmission matters. It does not mean the gearbox disappeared. It means the gearbox has been demoted. The brain is no longer inside the casing. The brain is above it, watching the road before the road happens. But predictive software means nothing if the physical body cannot survive the forces it is commanding. This is where the Lynk Co 10 EMP becomes more than a powertrain story. It is not enough to predict torque. The chassis has to absorb it. It is not enough to prepare the engine before a hill. The suspension has to keep the tires planted when mass speed and road surface start pulling the vehicle in different directions. This is the old problem Detroit understands very well. Weight is never just weight. In a vehicle above 2 tons, mass becomes a moving debt. Under braking, it dives forward. In a corner, it rolls outward. Under acceleration, it shifts rearward. On broken pavement, it sends shock through the structure, like a hammer through bone. Add a battery electric motors hybrid hardware and executive sedan expectations, and the engineering problem becomes brutal. Geely's answer is not simply to make the springs harder and call it performance. The platform uses a rigid body structure, high-strength materials, and a suspension layout that carries the shadow of Lotus engineering. A double wishbone front setup gives the car more control over tire angle under load. A 5-link independent rear suspension gives the rear axle more freedom to manage traction, comfort, and stability at the same time. Then the active damping system turns that mechanical foundation into something more dangerous. When the car enters a fast corner, the system can stiffen the outer dampers to resist body roll. When the road turns rough, it can open the valves and let the suspension breathe. The goal is not comfort alone. The goal is control. The rear electric motor cannot deploy instant torque if the chassis is floating, twisting, or fighting itself. That is the hidden meaning of Lotus DNA inside a Chinese hybrid sedan. It is not nostalgia. It is not branding. It is the conversion of old-world chassis knowledge into a digitally managed platform. And for American automakers, that is the uncomfortable part. Geely is not choosing between software and physics. It is trying to make software command physics. Luxury used to be easy to describe. Soft leather, thick carpet, a quiet door shut, a large screen, a premium badge on the steering wheel. But in a high-performance plug-in hybrid, real luxury is not decoration. It is acoustic warfare. The cabin is sitting above a battlefield of electric motors, inverters, tires, airflow, battery cooling systems, and a combustion engine that may start and stop without warning. This is where many legacy vehicles still use an old solution: add more material, more insulation in the doors, more padding under the floor, more mass between the passenger and the machine. It works, but it is crude. Every extra pound used to bury noise is a pound. The drivetrain must move, stop cool, and justify. The Lynk Co 10EMP points toward a different philosophy. Instead of treating noise as something to bury under weight, it treats sound as a pattern to be hunted. Acoustic materials can be tuned to intercept specific frequencies. Active cancellation can send inverted sound waves into the cabin before low-frequency drone reaches the human ear. A dedicated cockpit chip can keep the interface audio processing and cabin systems moving without hesitation. That matters because refinement is no longer separate from efficiency. If a hybrid needs heavy insulation to feel premium, its own luxury becomes an engineering tax. But if it can erase noise through smarter materials, faster processing, and targeted cancellation, then comfort becomes part of the same computational ecosystem as torque, battery, heat, and suspension control. The cabin is no longer just where the driver sits. It becomes the final proof that the machine underneath is being controlled, disciplined, and hidden from human senses. This is where the threat moves beyond the Lynk Co 10EMP itself. A legacy automaker can buy a faster chip. It can announce a new hybrid system. It can hire software engineers, redesign a dashboard, and promise over-the-air updates. But copying a feature is not the same as copying an ecosystem. Detroit's problem is not a lack of engineering talent. Ford, GM, and Stellantis still understand trucks' durability, torque, towing, and American road abuse better than almost anyone. The problem is structural. Many legacy vehicles are built through supplier layers, old platforms, separate software teams, separate powertrain divisions, separate purchasing logic, and years of internal compromise before the customer ever sees the product. That structure works when the battlefield is mechanical improvement. A better V8, a stronger frame, a smoother automatic transmission, a tougher transfer case. But when the battlefield becomes synchronized computation, the old structure slows down. The battery team cannot wait for the chassis team. The transmission team cannot fight the software team. The ADAS system cannot behave like a guest living inside someone else's vehicle architecture. Look at the American benchmarks. The Ford F-150 dominates because it understands work. The Chevrolet Silverado survives because it understands scale. The Ram 1500 wins loyalty through comfort and torque. Tesla forced the industry to respect software. Jeep Wrangler owns an emotional territory that no spreadsheet can easily kill. But Geely is attacking a different layer. It is not asking whether a Chinese sedan can replace a pickup in Texas. It is asking whether the next generation of American vehicles can still afford to be assembled from disconnected brains. That is why reverse engineering will not be easy. You cannot simply tear down the car, identify the parts, and rebuild the threat. The threat is the coordination, the timing, the shared data layer, the way the engine, battery, transmission, suspension, and cabin systems behave like one organism. To answer that, Detroit does not just need a new gearbox, it may need a new nervous system. For years, the Western narrative around plug-in hybrids was simple. They were temporary, a bridge, a compromise, something consumers would use until battery electric vehicles became cheap enough chargers became everywhere, and range anxiety finally disappeared. In that story, the PHEV was never supposed to become the final weapon. It was supposed to fade away. But the Lynk Co 10EMP attacks that assumption. If a plug-in hybrid can deliver long electric driving for daily use, massive combined range for road trips, high thermal efficiency for highway cruising, and centralized compute for predictive energy control, then it is no longer just a halfway technology. It becomes a different answer to the American problem. That problem is not theoretical. It is the family crossing Texas with children in the back seat. It is the contractor towing equipment through Colorado. It is the Michigan driver watching cold weather punish battery range. It is the California commuter who wants electric driving but does not want to build life around a charger. A pure EV can solve some of these cases brilliantly, but it does not solve all of them equally. This is why Geely's direction is dangerous. It suggests that the future may not be a clean one-lane highway toward BEV dominance. It may be a split battlefield where the smartest hybrid systems keep combustion alive by making it computationally obedient, thermally efficient, and strategically invisible until needed. For Detroit, that is a brutal realization. The fight may not be EV versus gasoline anymore. The fight may be dumb energy versus intelligent energy. Part 9. The mechanical automobile has lost the throne. The gearbox is not dead because engineers forgot how to build gears. It is dying because the center of authority has moved. For a century, the automobile was judged by the beauty of its mechanical reactions. The shift, the pull, the roar, the grip, the timing of metal responding to the driver's command. But now, the command structure is changing. The Lynk Co 10EMP is not important because it is a sedan. It is important because it shows what happens when a drivetrain becomes part of a larger computational organism. The engine is no longer the king. The transmission is no longer the strategist. The battery is no longer just storage. The suspension is no longer just hardware. Every system becomes a limb controlled by one predictive brain. That is the industrial warning. Detroit does not need to panic, but it does need to understand the size of the shift. The next war will not be won by the company with the most nostalgic engine note or the most familiar badge. It will be won by the company that can make energy, software, metallurgy, thermal management, and motion obey the same logic. The mechanical automobile did not vanish overnight. It was surrounded, digitized, and absorbed. And now America has to decide whether it will defend the old machine or build the nervous system that replaces it.